Hi, let's move on to our next topic. Our next topic will be basic operations with vectors. From these basic operations with vectors, we already covered how to calculate the length, how to know or to find the components of a vector, how to sketch a vector in a three and two-dimensional coordinate systems. So let's start with some basic operations. The first one that we are going to cover is the vector addition. And for vector addition, if we have some vector A with components A sub 1, A sub 2, A sub 3, and vector B with components B sub 1, B sub 2, B sub 3, and we want to add them, then uh, the operation A plus B will be equal to A sub 1 plus B sub 1, A sub 2 plus B sub 2, and A sub 3 plus B sub 3. And that's it. That's the way that we can add two vectors. Uh, I remember this, just to remind you, this is taking the components of each one of these vectors. Um, Please recall that we need the coordinate system and the points located in the starting and ending point of these vectors to calculate these components. And once we have these components defined, we can add them together, just like I'm explaining here. So let's say that this is the numerically, and there's another way to do this operation, which is in a geometric way. So let me draw a little sketch here. So let's let's say that this we have these two vectors here, and let's say that this is vector A and this is vector B, and we want to add these vectors. So in the numerical operation, we just simply add the first z component to the second one with this one, and the third one with this one. And in a geometrical way, this is the parallelogram law. Okay, so A plus B in a geometrical way, we can move vector A and move we are moving vector B. This is vector B. And we are projecting vector A in this direction. So if we have these two vectors, we displace this vector to the top, to the ending of this, to the edge of this vector A, and we have this vector here, and we move the vector A right to the end of the vector B. We have these two lines, and then if we add these lines with another line, just like we are having here this vector addition. Let me do it in a fancy way. This is A plus B. Okay, so this is the parallelogram law, and this is the way that we can geometrically add two vectors. We have vector A and vector B, and the sum of these two, if you move the vector A to the end to the end of vector B, and you project the vector B to the end of vector A, and when these two converge in this point, we can draw a line from the origin to this, and this is geometrically the sum of the result from vector A plus vector B. If you want to demonstrate this, you can do this in a Cartesian plane, calculate the components, and do some measurements that you can demonstrate and confirm that this is true in both ways, in this way and in this way. Okay, so that's vector addition. Let's now do vector subtraction, or difference of vectors. And for this, let's say we have a vector A, and I want to subtract vector B. So if we want to do that operation, that will be equal to a component A sub 1 minus component B sub 1, component B sub 2 minus component B sub 2, and component A sub 3 minus component B sub 3. So this is the same as this, but with opposite sign. And if you want to do that in a geometrical way, you just, instead of moving this B vector to the end of the A vector and the A vector to the end of the B vector, what you're going to do there to make the to calculate the difference between these two vectors is you're going only to draw a line. Let me erase this, and let me get rid of this. So A minus B is just drawing this line, I minus B. So if you draw a line between these 2 points, you will have A minus B. So this is the numerical method, and this is the geometrical method according to the parallelogram law. And this is all for vector addition and vector subtraction.